How to use a frequency counter, part 2. At first I go back to my first video. Perhaps it was not so clear what I meant with the final part of this video. I wanted to point out that in such a measuring circuit with a pickup coil, this is a tuned circuit. So to this tuned circuit, this formula applies. It is parallel resonance, the parallel resonance formula. But here, this is also a tuned circuit. And the cable capacitance and the input capacitance from the counter and the input capacitance from the oscilloscope form together also a tuned circuit, and that means that here is parallel capacitance. So when this complete circuit here and this circuit here is tuned to the same frequency, you get a huge coupling from the signal from the oscillator to the pickup coil. So the frequency must match. The frequency from this part of the circuit must match with this part of the circuit. But of course, when there is a certain mismatch, this can also mean that the level goes down, the input level to the counter goes down, but it doesn't mean that the counter doesn't work properly. So when this circuit is not perfectly tuned to this circuit, it's also possible to get a good reading. There are, of course, some other issues, and that is that when you use the counter and use a coax cable, it's possible that the cable floats. And that means that there is no earth connection between the counter and the radio or oscillator or whatever circuit you want to measure. So there must be a connection here between the ground here, or the input here, and the ground here. Not always the ground means a connection to the chassis, but that's not relevant. There must be a connection, both connections, both points from the input from your counter must be connected to the circuit that you want to measure. If not, this cable floats above ground, the signal on this cable floats above ground, and you don't get enough energy transported. And in that case also the counter doesn't work. And this also means that you can also use no coax cable, but only a wire here to the circuit that you want to measure, and here the input also a wire. Of course the capacitance from only wires is much less compared to a coax coil, because these two separate wires have almost no capacitance opposite to each other. There is no influence. Now I want to do another demo. How do we know that the frequency that we see on the screen, that we can trust that frequency, that it's reliable? At first, of course, you have done measurements when you make an oscillator, and you must know it has to work, let's say, approximately on 30 kHz or so, or another frequency. So you can control that with the counter. And at first I want to demo the situation in which there's no earth connection. So this is the earth connection. I decoupled it now, it's not connected, and now this is the frequency that we read. When I make the earth connection from the counter to the oscillator, you can see that we read a totally other frequency, and this is the real frequency. It's 48 kHz, and you can check that whether this is the right frequency by calculations, but also by the rules from the tuned tank circuit, the laws that are applicable to such a tank circuit, that when we change the inductance here, I move the varied rod out now, take it out, pull it out, then the frequency must go up. So now it's pulled out. Now I stick it back into the coil. Now the frequency goes down again, and this means that we are measuring a reliable frequency. This is a small radio. Put a piece of paper under it. This is a small radio, and also here we can search for instance, the oscillator frequency from the tuning oscillator. It's a super heterodyne radio, so there must be an oscillator circuit in here, and you can hear it. So when you want to do some measurements in this radio, the first thing to do is to connect the counter to the minus. And that's here. The minus from the circuit is also the minus from the battery. So I connect the minus from the counter here. And now you can touch with the probe from your counter, or also eventually with a small capacitor, input capacitor, you can touch different parts inside the radio to search where you can find, for instance, the main oscillator. I did this already when I did some experiments to study this demo, and it's this green wire is connected to the oscillator. So I connect now my probe to this part of this radio, and now I can read on the counter 1.2 megahertz. And to test whether this is reliable, we can tune in to other radio stations, and then we find the frequency changing. So now I turn the tuning capacitor, and you can see that it goes up and goes down. And this also means that we have found in this radio the right location from the VFO, the variable frequency oscillator, the mains tuning oscillator. So this is also a demo. Connect your probe to the minus of the circuit and search with the other part, the yellow part here, the input from your counter, to locations, to the right location to find what you want to find.